Isotopes. Isotopes are atoms with the same number of protons. So, the number of protons on the bottom, they're both carbon. However, isotopes have different number of mass. That's the number on top. So the first one is called carbon-12, and the second one is called carbon-14. And with different mass, they have different neutrons. Isotope can be used as a substitute in a chemical reaction. For example, if a plant uses phosphorus-31, we can replace it with phosphorus-32, and the plant can use it just as well. Since both of them are phosphorus, same number of protons, they can be used by the plants. So what's the difference between these two? Well, some isotopes are radioactive. In this case, for example, phosphorus-32 is radioactive. Radioactive can be detected with certain devices that tells you where the element is. So for example, let's say the plant uses phosphorus-31 and we want to know where is it being used, which part of the plant. So what we do is we give it P32 instead, and that one is radioactive. So because it's radioactive, we can use the device and detect where it's being used, and voila, it glows in the dark. That tells us exactly where we can find the phosphorus are being used. Radioactive isotope is also used in medical use as well. So when we need to diagnose a person and where the problem is, we can find out by giving the person the radioactive isotope. It goes into the body and we can trace it. As it goes through the body or the organism, we can figure out where it's going to. So if we want to diagnose a problem, we give it the right element that we're looking for, goes through the body, goes to the location, and then with the device, we can detect where the situation is occurring at. That is radioactive. It's also called a radioactive tracer, being used to trace. So there are many application use for isotopes. This is just one of the many examples. Another example for the use of isotope is we can find out how old something is. That's called radioactive dating. No, it's not when two ions are going out. Radioactive dating, we can use it to find out the age of things that died. Yes, so it can only work on things that once lived and then died. It doesn't work on non-living things like water, wind, and such. Only things that once lived and died. So things that were alive produces carbon-14. However, once the organism died, it stopped producing carbon-14. Over time, the carbon-14 is converted to the isotope carbon-12. So as the number of carbon-14 is converted to carbon-12, the remaining carbon-14, the amount of percent left, using radioactive dating, scientists can determine how old something is. For example, this mummy right here, if there was 50% carbon-14 left, doing the math and such, this mummy is 5,700 years old. And that's radioactive dating. So isotopes have many uses. These are just a few examples. So they discover a new element called element M. And here's a chemical analysis of element M. The element name is Men, symbol M, atomic mass accepted at 70 kg. But it may vary from 50 kg to 150 kg. However, highly reactive at 150 kg or higher, so avoid at all costs. Further analysis of chemical M revealed the discoverer was Eve. Occurrence usually found near element WO, also known as woman, and it's found in higher concentration near perfect WO. The physical properties are as follows. It has high affinity for the group ROH, which is alcohol, tends to fall into very low energy state directly after reaction with WO. gains considerable mass as specimen age, loses reactive nature. Other physical properties: rarely found in pure form, often found in gaseous states, and often damaged as a direct result of unlucky reaction with polluted form of the WO common ore. Other properties: its high chemical reaction with various WO isotopes, has a great affinity for fatty substances, carbohydrate, lipids, you name it. Appearance greatly improves when placed in a sport car. The uses for element M: heavy boxes, top shelves, general repair. The isotopes for element M: highest chemical reaction near 18, 25-35 for favorable reaction, 35 plus reaction may vary.